Well, good afternoon, everyone, and welcome to the first e-learning session for the second semester of the Intro to Algebra program. My name is Helen Chan, and I will be your moderator for this afternoon, along with Mark Goldstein. Mark, give us a happy face so we know who you are. And Joe Packham, who is our techie person, and you know Joe. So for the next 30 minutes or so, we will be reviewing lessons 17.1 and 17.2 on proportional reasoning. And just to let you know, this session is also being recorded. As you can, I can see that Joe is already recording our session, so that you can view it later if you need a refresher on the highlights of these lessons. Okay. All right, so we will be presenting a series of 4 live sessions this afternoon. Okay, the one that I've highlighted in red is the one that you are in right now. You can see from the schedule that each session is approximately 30 minutes long with a 15-minute break in between. You're welcome to join us for all 4 sessions, or as I said, if you're not able to, they are all going to be recorded. Okay, so you can watch them when it's convenient for you. All you have to do to access the archives is to go to the our e-learning page on our website using the link that Joe emailed you earlier this week, okay, and just click on the watch session button next to the session that you want to access, okay. Now, if you are watching this as a pre-recorded session and need to contact us for any assistance, just feel free to email one of us, and we'll be happy to answer your questions. If you miss jotting down our email addresses right now, don't worry. We will put up our contact information again at the end of this session. Okay? Now, I'm going to go back to the first slide, which is our warm-up problem. So Pat joined us early, and she actually had enough time to do both of these problems using 2 methods each. So in the first, I'd like to just, instead of going over the answers, I'd like to ask you guys, how are these 2 pencil problems different? Okay, so take a look at the way these problems are worded, and see if you can tell me how these 2 pencil problems are different. Okay, Shelley says that one suggests multiplication, okay, and one suggests division. And you can see from Pat's work here that this is what Shelley's talking about. The first one is suggesting multiplication, while the second one we use division as a strategy. Okay, someone else, I think. Somebody else is administrating. Okay, and then one is asking you for the cost of 1 pencil, or in other words, the unit cost, and the other one asks for the cost of 1 pencil. Okay, one of them asks, I think I know what you're saying, is that in the first one, we're given the unit cost, and we're asked to find the cost of 4 pencils, whereas in the second problem, we are given the cost of 5 pencils, and we are being asked to determine the unit cost. Okay, does everyone agree with those observations? Okay, thank you, Mark. Thank you, everybody. Okay, now why do you think we ask students to solve problems, these types of problems, using 2 ways? What are some of the benefits of asking a student to solve problems 2 ways? Just to keep them busy? Wow, everybody's eager typing. Great, I like participation. Okay, Shelley says that it's flexible thinking, more access for students to think differently. Okay, multiple strategies is good for students. Okay, sharing ideas, yes, flexible. Yeah, so I think we all agree that it's it does, having multiple strategies is showing flexibility and confidence. I think confidence in the mathematics. I also thought that it was a good way for students to self-check the answers, because if they got two different answers using two different strategies, then one of them is wrong. So that's a quick way for students to kind of self-check their answers. And it also, and I'm glad that Pat showed this on the whiteboard, is that some students may already know how to set up proportions and solve a problem. And they may or may not know the meaning of proportional reasoning, but if they showed that as a strategy, it kind of forces them to think of another sense-making strategy to solve the problem. Okay, it's kind of like what you guys were saying earlier about the flexibility. So I just wanted to point that out. That we're not just trying to give them, keep them busy. That there is actually a reason behind why we're asking them to do two methods. Okay, so we move on. So here are the content goals for 17.1 and 17.2. These are taken straight out of your student pages. So I'm not going to go ahead and I'm not going to read them because you can probably look at them. But I do want to emphasize that the problems in these lessons should be solved using sense-making strategies rather than setting up proportions. Okay. Even though if a student already knows how to set up and solve proportions, you can do that if they already know. But know that cross multiplication is just another trick if students don't understand why the strategy works. And our program doesn't introduce solving proportions, the setting up of proportions until week 20. Right now, we just want to focus on, as I'm sure that was Joe who highlighted this, using sense-making strategies. Okay. All right. The next one here is showing a math background page that's taken from the Week 17 teacher guide. You want to take a look at this math background before you teach a lesson to your students. I think it's helpful because it explains why we use sense-making strategies for solving proportional reasoning problems rather. And it actually, this problem that you see here of how much will 5 pencils cost if 8 pencils cost $4.40. This is actually a problem taken from SP3. It's number 7 on SP3, which you'll see later on. Okay. So just make sure you review that page. Okay. So here are 4 pencil problems from SP2. Okay. And each one, again, just like the warm-up we had, is to be solved using 2 different strategies. Now, a good idea, I think, would be to have the students work in pairs, because then you can encourage them to use each other's strategies to solve the next problem. You can also encourage the students to come up with a different way to solve the next problem. And if you have Pat, just curious, do you have a document camera in your classroom? Like an Elmo, maybe? Oh, you do? Okay, great, because then it's just, I think having a document camera in the classroom makes it sharing, of strategies a lot quicker and a lot easier. And this would be a great opportunity to, make use of that fancy equipment that you have. So Joe, I'd like you to set the timer for me for 1 minute, okay? And I'm gonna, don't worry if we run out of time. I just want you to give a try, and if you don't come up with 2 strategies before time's up, not a big deal. I just want you to get a little taste of, these problems, okay? So go ahead. I'm going to assign Pat. Go ahead and do number 1 for us. Mark, you can do number 2. Okay. Shelly, you can do number 3. And Cynthia, thank you for joining us. You can do problem number 4. Again, don't worry if we run out of time and you only have 1 strategy shown. Okay? So I'll be quiet for a moment and give you, time to do your work. Oopsies. Thank you. I was just asking if Mark was doing the second problem. I might have gotten these mixed up, but I was just putting the names next to the problems. Any comments about these problems as you were doing them? What do you find challenging about these problems? Or do you have any comments? Is it pretty straightforward? Okay. So I see a happy face from Pat that she thinks they're pretty straightforward. Okay. Yeah, they seem to. Okay, so Shelley likes doing them two different ways. Again, yeah, I agree with that. I think it does help students to not be so narrow-minded and so reliant on a like a prescribed way of doing it. It really, when you ask them to do it two different ways, it really helps them to kind of to be critical thinkers, okay, and to really understand what the problem is asking them to do, okay. I think it's almost harder for adults to try two ways. For kids, I think it might come easier, probably. If I had not said use sense-making strategies, maybe some of us would have done just setting up proportions instead of doing it using a sense-making way, okay. So, any questions? Okay, no questions. All right, so I'm going to move on to the next slide. Now here are some more, 4 more pencil problems that the students have for independent practice. We're not actually going to solve them right now, but I'd like you to look at problems number 5 and number 6, okay? I apologize for that ringing in the back. It'll go away soon. I want you to think about what is the difference between problems number 5 and number 6. More specifically, think about how do you think the number of pencils in each answer, okay, because each one of us is asking is how many pencils. The answer is going to be how many pencils. How do you think the number of pencils in each answer compares to the number of pencils given in the problem? Mark, if you have another way, a better way of phrasing that question, just let me know. Okay, so I'm looking at this, say for example, number 5. We're given that the cost is 9 pencils, okay, for $1.89. Okay, and then now we're asking the students, how many pencils can they buy with $2.52. Okay, I'm going to guide you a little bit here. Look at, it's $1.89 for 9 pencils, and now the amount is $2.52. Does everybody see what I'm trying to get at? Okay, I see some of the chat things in the chat box. Okay, so first one will be more. That is correct, Shelley. The answer is going to be more than 9 pencils because the cost, because the amount that we have now is more, okay? And the second one is going to be less because, okay, because we're given that 6 pencils is $1.44, but if we only have 48 cents, we're obviously going to not be able to buy 6 pencils. We're going to be able to buy less pencils, okay? And Pat is saying, oh, Mark, sorry, you're next. How can kids reason about that? Okay, that was just a way of phrasing the question better. Okay, Pat is saying, I think students have an easier time doing unit rate, okay, but are struggling with knowing the cost. Okay, so you think that students, yeah, probably unit rate would be, so because to find the unit rate, you just divide the $1.89 by 9, and then once you find the unit cost, then you can figure out how many pencils can be purchased with $2.52. Okay, Mark is saying that He agrees with Shelley. Okay. Cynthia, I like looking at the problem from an estimation of cost, not always worrying about the exact. Okay. Yeah. It's really just for students to see, does their answer make sense? Again, we want to encourage common sense. Okay. If they get an answer that is less, for example, in number 5, if the students come up with, say, 3 pencils, I would like them to know that they did something wrong. I would like them to know for themselves that they did something wrong, because the cost, we have more money. So we obviously going to buy more pencils than 9. So, okay. All right. So, and then the same thing with number 7 and number 8. Those two, if you compare them side by side. Okay, except that this time now, instead of asking them for the how many pencils can be purchased, it's how much the pencils are going to cost. Okay, but again, if we are asking, for example, in number 5 to buy 5 pencils, and we know that 8 pencils cost $4.40, then the cost of 5 pencils needs to be less than $4.40. Does that make sense? Give me a happy face or a sad face if you agree or disagree. Okay, great. Do you have any questions? Okay, let's move on. Okay, Joe, do me a favor. Would you please partition this whiteboard, say, into 4? Four different parts, because I want 4 different volunteers to do this problem. While Joe is doing that, let me tell you what I'd like you to do. So now we're moving into lesson 7.2, okay, where students are still using sense-making strategies. Now they're finding percents of numbers, okay? And the lesson really emphasizes on the use of visuals and familiar context and mental math strategies. Okay, what I'd like to have you do, okay, let's see, 1, 2, 3, 4, yeah, just 4 of you, not including Joe. So Joe, you're not going to participate on this one. Everybody else, Cynthia will claim the upper left-hand corner. Shelley will claim the upper right-hand corner. Mark, you will claim the lower left hand. And Pat, you will do the lower right hand. And thank you for whoever, I think Joe's, yeah, Joe, thank you for writing everybody's name on it. Now, we're going to give you 1 minute, okay? And what I'd like you to do is use a strategy to find 17% of 84. And if you still have time after your one strategy, you can go ahead and do another one in the same workspace that you have, okay? So, Joe, if you would please set the timer for 1 minute. Thank you. Joe, just as an aside to you, thank you for not setting the timer until I finish giving the instructions, because otherwise it would eat up into the time that they, have to work. Okay, that is the end of the time, the 1 minute. Well, you guys work really fast on this one. So let's just everybody look at the strategies that the other 3 people used. Okay, I see that Mark and Shelley used pretty much the same strategy. Okay, and then Cynthia. I think what Cynthia is trying to do, and you can later, after I explain Cynthia, you can show happy face or sad face if this is what you were trying to do. Cynthia, again, remember that the problem is 17% of 84, so she started out with 20%, okay? So she, in her mind, she probably had 10% figured out and doubled that. So she figured it was 16.8. And then she figured out that 1% is 0.84, and then 2% would just be double that. So then she was probably trying to take the 20% and then subtract the 1% and subtract the 2% to get the 17%. Is that right, Cynthia? I see happy face. So, okay, so you must be eagerly agreeing with what I'm saying, okay? And then Pat, let me see. 10% is 8.4, 5% is 4.2. Okay, so it's half of that, good. And then 1%. Okay, so it's pretty much, were you trying to do something very similar to Shelley and Mark's strategy, Pat? Yeah, okay, so yeah, great minds think alike. And you guys are all, you know, advanced students now. You don't need this session because you're all using sense-making strategies. Great, okay. Any questions? Okay, guess what I did on the next slide? You guys already came up with this, so there is no need for me to go over this slide because I was afraid that me as Little Face thought that, you know, I needed to introduce some of these strategies to you, but this is exactly what you guys did. So, so that's great. Saves me time going over the slide with you. But one thing I want to point out while we're here is that this particular problem of finding 17% of 84 is in your teacher guide. Okay, not sure if everybody has access to the teacher guide, but excuse me, this is in the extend section of week 17. It's intended as a way of transitioning the students, okay, into the procedural method of multiplying to find a percent of a number. But this is written as an extend in the teacher guide, not the student guide. Okay. Oh, okay. Mark, I see. Mark has already. Indicated that. So Shelley is asking, is this an important extent that everyone should do? I would leave that up to the teacher, but you can see here that, you know, we were able to do this one using sense-making strategies. Okay. I think the point is maybe eventually to kind of use some numbers that are not as friendly but still doable using sense-making strategies as a way of introducing, you know, setting up proportions to solve these types of problems. Okay? Does that answer your question, Shelley? Yes, it's coming up. Okay, so this is SP6 in week 17. Okay, this is, if you have your student packet in front of you, notice that this is only the top half of the page, and this is only the part that I want you to focus on because the bottom part is actually very similar. Okay, so we begin with a set of 4 containers. Okay, in the chat box, I want everyone to type in the percentage that you think container A is full. What percent do you think container A is full? In the chat box. Okay, good. How about container B? What percent? Okay. How about C? Okay, and D. Okay. Yeah. Okay. So when we do this, people generally do not disagree on A, B, and C. It's D where we start getting, you know, the 10%, around 10%, 12.5. Although I think I tend to see 12.5 more often because the way we set up the problems, how it looks like every time it's half of the previous container. Okay, so 12.5 seems to be the more popular response, but we do often get other ones that such as 10%. One thing I would point out is that think about how difficult a problem would be if we just had given you D and asked you to determine like what estimate about what percentage. Okay, I think it would be a little bit more challenging than the way it's set up here, where we give them, you know, the set of 4 containers, because you can kind of rely on the previous one to figure out what the next one is going to be. Okay. So here on number 2, you are using still the containers, okay? And we're gonna operate under the assumption that these are the percentages full that they are, okay? And now we're gonna say that the container, when it's full, holds 800 ounces of liquid, okay? So if that's true, if that's the case, then container A would hold 800 ounces. Container B would hold 50% of that, or half of that would be 400, okay? And then what would container C hold? Okay. And what about container D then? Okay. All right. And then the next one, which we're not going to do because I see I'm running out of time, it's just more of the same, but the numbers are, it's now instead of 800, it's 900 ounces. Okay. All right. This is a little alternative way that you can do the do problem number 5 on SP7. What sometimes we recommend in PDs for teachers is to cut out strips of papers like this using a like a 1 meter and put the students to work in groups, and then have them, when they finish locating these percentages, to tape up the adding machine tape vertically so that the students, the different groups can quickly compare to see how accurate they were in locating these percentages. So that's just another, like a teaching tip for you, okay? And the last one that we have about 2 minutes to do is I'd like you to try this for about a minute, okay, to do each of these problems across. So Pat, if I can have you do number 1. Okay, so you're going to take $30, find 10% of $30, 5%, 15%, and then 20%. Okay? Cynthia, you do number, the next one, which is number 5. The numbers skip around because I just chose selected problems from SP9. Okay? Shelly, you'll do number 9, and Mark, you will do number 11. Okay? And more importantly, I want you to think about how, as you're doing the problems across, how does doing one problem help you figure out the next problem across the same row? Okay? Think about the strategy that you're using. Thank you, and I forgot to remind you about the timer, but thank you, Joe. And if you have a comment to make, you can type it in your chat box. So again, the question is, how does doing one problem help lead you, to figure out the next problem in the same row? You guys are great participants, by the way. Everybody's just working so efficiently. Okay, I see Cynthia has a comment there. Once you find 10%, 10%, you either half for 5% or double for 20. Great. Okay, and that's what mental strategies is really about. Is knowing when you can use half something, take half of something, or double. Okay. Pat said 10% and half of 10. 5, then add them together to get, okay, to double the 10. Okay. Once I found 12, then look for relationships between the percent and what I knew. Okay. So does that make sense? Does it make sense what we are talking about here? Okay. Great. Okay. Well, we're 1 minute over, but we made it. Yay. So Thank you very much. You guys are great participants. That's the end of the session. Don't forget that the next session starts at 2:45. Okay, but I believe you can log in right now already. And just know if we're going to have the warm-up problem ready to go before 2:45, but the 2:45 is the actual official start time. Okay. You do have to log out of the session in order to log into the next session. So make sure you do that if you want to join us. And Mark, if you don't mind staying for, it looks like, oh, guess what? So we're all there. Mark, you don't need to stay on then. We're just going to close up this this session. Okay, so if you all want to just